Hi, this is Sushant, and we are going to discuss about radioactivity. So, radioactivity is a spontaneous process. It is a nuclear phenomenon in which the unstable nucleus becomes stable by emitting some sort of radiation, that is alpha, beta, and gamma radiation. So, in radioactivity, unstable nucleus or unstable nuclei become stable So the process in which the unstable nuclei become stable is radioactivity, and in the process they do emit radiation. And the radiation is in the form of alpha, beta, and gamma. So this is technically the definition of what radioactivity means, what is the meaning of radioactivity, and beside this, the two key terms we have to understand to figure out what is unstable nuclei means, and another thing is the radiation, that is alpha, beta, gamma. What are these? What is alpha, beta, and gamma? So on confirming the unstable nuclei, we have to focus on few things. We will discuss about the unstable nuclei in the further coming videos, but on a very light note, if you have to talk about the unstable nuclei, we can say the larger size nuclei are technically unstable, and that is why, because for the very larger size nuclei, the coulombic repulsion for the charges that are being at the very opposite end of the nucleus is much more stronger than the strong nuclear force that is binding the positive charges and nucleus altogether. So the binding force, the attractive force due to strong nuclear force, is in dominance for a smaller size nucleus, and the coulombic repulsion overcomes the strong nuclear force when the size of the nucleus increases. As the strong nuclear force is a very short range force that can act for only 1 to 3 femtometer, so when the size of the nucleus increases, it automatically becomes unstable and it loses its stability. So one of the reasons for unstable nuclei is the size of the nucleus, and as we see in the periodic table, most of the radioactive substance, either uranium, thorium, plutonium, radium, cesium, francium, so all these are the heavy sized atoms. So the heavy size at the bigger size nucleus becomes unstable technically, and the second element for defining the unstability of the nucleus is the Zn graph, the proton-neutron ratio. So the proton-neutron ratio also define the stability of the nucleus. So when the ratio of proton or neutron is not in actual or in exact amount that it has to be to become naturally stable, it automatically become unstable. So either of the cases, either due to the size or due to the alternation of this proton and neutron ratio, the nucleus automatically become unstable. And as the nature tends to stability, the nature of any things technically leads toward the stability. So in the process of gaining the stability, they have to radiate, they have to emit some sort of things inside from the nucleus, and the things are radiations, and the radiation is being categorized into three, that is alpha, beta, and gamma. If we have to delve deep into this form of radiation, so one is alpha, and alpha is nothing but a helium nucleus. Alpha is nothing but a nucleus of helium, and beta is nothing but it is a electron or an anti-electron particle. And that anti-electron particle is called positron. And another is gamma, which is nothing but an electromagnetic oscillation, which is an electromagnetic wave. So for the very first place, what we should focus on is we are considering all these three in form of radiation, but as we can clearly see that alpha and beta are electron or positron, that are the particles, and a helium nucleus, that is the particle 2. So how we are categorizing these particles in form of radiation? So the very technical and the ancient initial traditional definition of radiation, what we perceive it as a electromagnetic oscillation. So light is a form of radiation. Anything that is an electromagnetic oscillation, we are categorizing in the form of radiation. But the redefining the definition of radiation, what we now perceive radiation as a anything, either massable particles or energy that is possessing some sort of energy and that have some sort of penetrating power, ionizing power, they are categorized in the form of radiation. As we can say, the alpha particle, which is a particle, is being categorized in the form of radiation because they have penetrating power. They can ionize the particles of the medium in which they are propagating, in which they are traveling. So they have ionizing potential, they have ionizing power, as the electron or positron, that is a beta particle, do have the ionizing power. The gamma radiation do have ionizing power and emitting ionizing power, and they can penetrate to some extent. Like these radiations, in which the first two radiation are massable radiation, we are considering it as a massable radiation. The alpha particle can penetrate, and is processing some sort of energy to some extent. Like alpha particle can penetrate few sheets of paper. It has penetrating power, and it's very low, the least in the list, so it can penetrate to few sheets of paper. The beta particle has a penetrating power higher than the alpha particle, and smaller, less than the gamma radiation. So the beta, the electron or positron that is emitted by the unstable nucleus, this particle are being emitted by the unstable nucleus. Unstable, we earlier talked about unstability of nucleus can be defined in two ways. Either the size of the nucleus is being huge, that the coulombic repulsion is overcoming the strong nuclear force, and the strong nuclear force is not sufficient enough to hold it in a stable equilibrium, so it becomes unstable, and it has to emit either of this radiation to gain stability, to reduce its size in a way. And the another is PN graph. So when the Zn graph, the proton and neutron ratio is being altered into the nucleus, then also it becomes unstable, and at that instant also the nucleus has to emit any of this radiation to become stable. So the electron has penetrating power too, and its penetration is to a greater extent, that it can penetrate few sheets of metal, few aluminum foil, we can say, very thin but very few sheets of metal can be also being penetrated by this beta particle. The very another form of radiation that is being emitted by the unstable nucleus is gamma. That is nothing, an electromagnetic oscillation, electromagnetic wave, and it has the maximum penetrating power among all the radiation emitted by the unstable radioactive nucleus. So unstable nucleus are the radioactive nucleus. These are the thing that we can correlate, that the unstable nucleus are the radioactive nucleus, and radioactive nucleus will emit the radiation to become stable, to become balanced. And the stability of the nucleus is not the absolute stability of the nucleus. By emitting some sort of radiation, the nucleus become more stable than the earlier version, but is not the most stable version of the nucleus. It is gaining the stability, but the stability of the nucleus is comparatively more. The stability is comparatively more than the earlier version. So by emitting this radiation in the multiple steps, in the multiple aspect, it is becoming more and more and more stable. And as we know that the iron and the nickel has the most stable nucleus, so their approach is trying to tends to the maximum stability level by emitting such sort of radiation. And the gamma radiation that we were talking about, it has the maximum penetrating power, so it can penetrate even through lead. So the maximum penetrating power, and these two are the charge carrier too. The electron is electron or positron, electron or anti-electron particles, so they are possessing a positive or negative charge. And the helium nucleus is itself a nucleus possessing two positive charge and two chargeless particle, that is neutron. And this proton and neutron, two proton and two neutron, that is a nucleus of a helium, all together are said to be alpha particle. And as they are also possessing two positive charge, so this alpha particle, alpha and beta, is being affected by electric and magnetic field, because electric field and magnetic field both are exerting force on the moving charge particles. But gamma radiation have no sort of deviation, deflection due to any electric or magnetic field. Gamma radiation is nothing but some sort of these are the photon, gamma photon, that is being radiated by the unstable nucleus. So these are the radiation emitted from the unstable nuclei, and the unstable nuclei we will discuss it in the further video in dipping down, delve into the context. And for this we have to focus this much, and the coming video we will discuss more on this.